Ladies and gentlemen, we will have the next talk. It's about the topic MySQL InnoDB Cluster Best Practice. And it's my very honor to introduce our next speaker, one of the amazing speakers we have this event. He's the MySQL Senior Solution Engineering Manager at Oracle. Please give him a warm welcome, everyone.
Okay. Thank you. Thank you, everyone. It's an honor to be able to share MySQL at the FOSSASIA in Bangkok. My name is Ivan Du. I'm from Oracle. I also organized MySQL user group in Taiwan, which was quite active. We have more than 6,000 participants in our group. And this talk is talking about the, I think MySQL high believe been addressed quite a few years, and this is I think the most, I think the number one MySQL HA feature that we are focused on from Oracle, which is InnoDB Cluster. Talking about the HA, the policy of HA is just, we don't keep all the eggs within a single basket. So we have many baskets. Once we lost one basket, we can still find the data from another database or another basket. Yeah, but the problem is how can you make sure the data is exactly the same between each instance? Because database is a state for the database has state. So how can you make sure that the data will be synced to the rest of the instance timely? This is something that we need to consider. This architecture has been, been there quite a few years since I think since MySQL 4. It's already been there. It's a kind of a single replication, or now we call this the source replica architecture. This is a single replication that we use the database. The application connect to the database, to the master server, or to the source server. And once we issue the transaction will goes into binary log first, and then it will flow into storage engine itself. So binary log will contain all the data, and the rest of the slash server or rest of the replica server, they can configure that your source database is at which host, the port number, and the username that are going to access the database, access the master server, and then issue start replica. Once it starts replica, there will be two threads running on the replica server. The first one is the IO thread. IO thread will take the data from the binary log and insert into its relay log. It now will goes into the database directly, but keep in the relay log for the time being. And another set of a thread we call apply thread. We can have multiple apply threads now. So it will help us to improve the performance of the replication. The apply thread will take data from relay log. So once the transaction be issued against the master server, once the transaction move into the storage engine itself, the application can issue the next transaction. So we are at some extreme situation where the master server is very busy. There can be some kind of a lag between the master server and the slash server, or source server and the replica server. So once the master server went down, there's some gap. There's some data still not be able to replicate to the replica server. So once we use this kind of architecture to do failover, from the master server to replica slash server, there might be some data loss. So the improvement is we create kind of a architecture that supports long loss failover, which means that we guarantee all the data will keep into the all the data will be shows on the select server or now we call it replica server. The thing is that we come actually this is not a single product. It's kind of a combination of a three product itself. The core is the group application itself. Called group application. The group application is kind of a we used to have a plugin module when we still have 5.7. Now after 5.8, it is come with a database itself. It is already embedded into the database itself. There's a module and each database we call GCM, Group Communication Module. And then we offer a tool, a client tool we call MySQL Share. MySQL Share, I think, is a kind of a new generation of MySQL client. It's very powerful. It has many interfaces. It also helps us to access the data with a SQL command, or with a JavaScript, or with Python. Once you use JavaScript or Python to access the MySQL database, that means you can access data, access MySQL. You can treat MySQL as kind of a document store database, as kind of document store database. There's one interface we call DBA. DBA interface is dedicated for InnoDB cluster. You can use the DBA interface to create cluster, to add a node to the cluster, and do failover and do any kind of operation, backup, something like that. You can use a MySQL to do that. Once you do some kind of configuration with MySQL Share, there were kind of a metadata schema. We call it InnoDB cluster metadata schema created under each node, each MySQL database. And those database can offer, those schema can offer the configuration information of the whole group application. And there's one middle tier we call MySQL router. MySQL router is running between your application server and the database. Your application server do not need to know how many data contained in the cluster, and which node is a primary node. If it is primary node, it is primary mode. If it is a single primary mode, of course, group application can also support multiple primary nodes. The router will dispatch the SQL command from application server to find the right node to return the data and to do the required operations. This is the core of the whole InnoDB cluster. It's a group application. With group application, as I mentioned, that there's a group communication module come with the database. It is already embedded after 8.0, so that means that we don't need to configure the plugin, and of course you can configure the group application without InnoDB cluster, but there's no metadata come with that. If you configure that directly to the group application directly without through MySQL Share. So there's no way to do some kind of SQL dispatching or to any kind of auto failover for the group application. So normally I will prefer to use MySQL Share to do this kind of configuration. Once the application dispatch a SQL command, dispatch any kind of a change against the database, if either it is a single primary node, it is a primary node, or it is multiple primary node. Any node can write, any database can write. There is a kind of enhanced parsing algorithm to make sure that every change will be propagated to the rest of the node when it is failover. Basically, the group application is based on traditional just based on the, traditional synchronization. But with the Paxo algorithm, it will help us to guarantee the data will not be lost when we do failover. And the data will automatically synchronize between each node. Automatically synchronize between each node. And once there's a kind of once the node, the primary node is went down, the rest of the node will automatically pick one node as its new primary node. So this is a right failover that can. This is how we can do the failover. And if we configure the groupification with MySQL share, this kind of change will write into the metadata schema, the InnoDB class metadata schema. So the router will know that. And so this is a way that we can do this kind of almost transparent failover with this kind of architecture. And there's an architecture sit on top of InnoDB cluster we call InnoDB cluster set. It is for cross-site replication or cross-class replication. The things that we can configure two more cluster. Each class contains a certain node of the MySQL database into the cluster. Basically, the membership, the number of nodes should be odd number, which means 3. You can have a 3 node, 5 node, 7 node. The maximum number of the node within a groupification is the 9 node, a 9 node cluster. So the minima should be 3. The minima should be 3. So in this architecture shows that there are 2 clusters. Each cluster has 3 nodes, and you can set up with the InnoDB cluster set. You can specify which class is the primary cluster, and once you configure the MySQL router with the InnoDB cluster set, the router will know that its configuration. Router will know that there are 6 nodes there, and there are 2 clusters, which class is the primary. And if the transaction is the right transaction, the router will dispatch to the primary cluster, the primary node of the primary cluster. And it will also help you, and the router will also help you to do failover. Once the this primary node is fed, the router will query against the router will query against any kind of any nodes of the cluster to know that there's a configuration change. Because the information is kept on its metadata schema. So the router will know there's configuration change. So the right transaction will dispatch to the next primary to the new primary nodes. And even if it is cross-cluster, access. For say this is the primary node, and the router, once the router accesses the primary node, once the router sitting on another data center of the cluster, the router will know the change. The router will also do some kind of failover for you. And with this kind of failover, because it's sitting on top of a groupification, so the data will not be lost because we can set and we can also set a replication level. We used to, by default, when we still have at 5.7, the default value is inventory, which means once we do failover, when the failover from the primary to the next primary, there might be some data loss in the first, maybe some kind of data loss in the first few seconds, because the time is needed is to digest the data that not synchronized to the new node yet. But after MySQL 8, we set its default consistency level to after primary failover, which means that once the failover happened, the router will pause a while to wait all the data being digested, all the data on the air being digested into new nodes. Yeah, and once we get a new connection, the data will be, all the changes will be there, or there will be no data loss once we do this kind of failover. That is the MySQL cluster. And if you want to configure MySQL cluster, I think the process should be very easy. The first thing is that we need to specify. For say, if we have a 3 node with our cluster, each server need to be able to access to each other. So the first thing maybe we need to lift the firewall. We need to do the firewall and let the node let the server can see each other. And then the first thing is that we use MySQL share. This is MySQL command, specified in JavaScript mode. And first is configure instance. This command is to try, this command will do some change against the database and to set up some configuration that the database be able to join the cluster, the InnoDB cluster. And then we can issue create cluster. After we do some change against the database, we can issue a cluster with a MySQL share create cluster command, which will create a cluster with only 1 node. And then the next thing is that we can add the instance. We can add instance to the cluster. The thing is to specify the second node, to specify where is the second node. And we can also specify how the second node can synchronize with the primary node. We can use a clone, or we can use manually. If we specify clone, the data will be automatically to copy or clone from the primary node to the new node to the second node. And once we do the add instance twice, we can get a cluster with 3 nodes. And you can also check the status for, say, this one. Once we add another node, when we issue class status, it will show there's a 2 nodes. And once we do it twice, add the third node to the cluster, the status will show there are 3 nodes in cluster. Which node is the primary, something like that. And the next thing is to configure the router. The first is use MySQL router to bootstrap the router and specify any of the node, any node, to create against the metadata schema. And once the bootstrap, we start the router. The router will know that there are 3 nodes within the cluster, which node is the primary node, and then we can configure that. We can get a cluster that help us to do failover with MySQL. And we can also set up the weight. The weight means that which cluster have more probability to become a primary once we do a cluster select. And we can also do kind of failover, or maybe sometimes we need to do some maintenance. We can control. We can manually to switch over. We can manually switch over from the primary to the secondary, which use the command to switch over. And once the primary is failed, the failover will be automatically happen. The rest of the node will pick 1 node as a new primary, and the router will automatically to to dispatch a request to the new primary because you are doing write. And if the database, if the whole cluster been shut down, and once you bring up, you need to start from total shutdown. You can use the MySQL share to do that. And once the node is done, and you can also once the node has been done, being resumed, you can also specify that you can resume the node. And once there's some, if you do some manual, if you touch the metadata schema, the metadata might not be synchronized. You can also use the scan command to rebuild the schema. And you can also do remove instance, add instance with MySQL share. And sometimes if you experience that you lost most of the node, the whole class will be shut down or either be into a kind of read-only mode. But in that case, you want to let the single node be able to run in to be able to support. You can force the cluster. You can force the class. You can force the Chrome using partition of specify which node is where to take the transaction alone to be able to continue the rest of the transaction. And once the node are being, once the rest of the node being resumed, you can resume the instance. You can resume instance with the MySQL share. Yeah. So if you want to use InnoDB cluster if you want backup InnoDB cluster, what we can do is use dump instance command. That means that the dump instance will use a Chrome Visual MySQL share dump instance command to back up the data, to take the data out, and with a multiple thread. Yeah, basically this is some kind of operation. Yeah. So with MySQL share, you can also use enterprise backup if you are MySQL enterprise user. Yeah. So basically, this is all about InnoDB cluster that which help us, offer us kind of very easy use, very mature, ready to use HA solution for that. Yep, this is my presentation. Thank you very much.